let's start. You still can see my screen, right? Okay, great. Yeah, I cannot see the green box anymore. I don't know where it is. Anyway, let's start. So introduction to data science. This is a very short small section. What is data science? In one sentence, it is the science of extracting meaningful information from data. It is a very general idea or concept. Just try to extract meaningful information from data. And this is a Venn diagram that sort of illustrates the meaning of data science. It is in the intersection of three areas of knowledge: statistics, math and statistics, hacking skills. So this is actually coding skills. Okay, and the last one is expertise. So data science is right in the middle of these three areas. And the intersection between coding and statistics is machine learning. So our class will focus on data science and machine learning. So this is another version of the Venn diagram about data science, which provides more details. For example, in the statistics, so these tools or techniques will be very useful, like advanced math, experimental design, model fitting, packages, and encoding part or computer science part, talk about how to get the right data, how to prepare data, because most of the machine learning models require pre-processing of data, because they are kind of picky, right? And then data governance SQL is used to query data, right? Database management. And then, so this Venn diagram uses a marketing context, substantive expertise, for example. So this is related to the question you want to answer. And also you need to understand the data using your expert knowledge. Otherwise, the problem might be framed in the wrong way and consequently answered in the wrong way. So expertise is also very important. And key ideas about data science is it combines statistics and computer science, and it is best applied in the context of expert knowledge. So statistics and computer science provide the technique support, the tools, and domain knowledge provides the context. And lastly, data scientists convert abundant data to actionable information, which means, yeah, nowadays data is very available. Maybe too much. We have too much data. The point is how to summarize the data so that we can get some actionable information, get some information to make decision, make the right decision. And what is the relationship between data science and statistics? So in this diagram, so the middle bubbles are corresponding to topics in traditional statistics, starting from raising a research question and then go to collect data or do some experiment to get data, and then figure out some statistical method to analyze the data we have. Usually we say we have some sample data. The data is a sample, it's not the whole population. And then the next step is how to extend the conclusion we made from the sample data to a larger population. So this is the inference part. And then present your result to your supervisor, or boss, or clients, right? And lastly, answer a question. So this is the traditional path for a statistical analysis. And the bubbles are about data science, so they are kind of added to the skeleton in the middle. Okay, so including, for example, data acquisition, data processing, cleaning, management, storage, data retrieval. And then here in methods, like data mining, machine learning, regression. So traditionally, in statistics, the methods are kind of focusing on how to make conclusion using limited data, right? Maybe a very small data set. But nowadays, it's kind of different. We have a lot of data usually. And the key point is how to make valuable decision, how to better summarize the data. So more computational methods will be used. For example, using bootstrapping, resampling, simulation, computational methods to solve problems. And then computational. So this is a relationship between statistics and data science. So they have the common goal, which is extracting meaningful information from data, but they have different focuses. Statistics focuses on creating methods that will maximize the strength of inference one is able to make given the least amount of data. Okay, so that is because previously, usually we have only a small data set. And in data science, the focus is on data management, visualization, modeling, and prediction, particularly prediction, and decision-making and communication. And these two are two data science projects, small articles you can read if you want. Sorry, links. Textbooks. So this is a textbook we will use in the class, the first textbook. And the reference book is Alpha Data Science. I'll show you here. This is the second edition. Yeah, everything is available for you. Everyone, it's open. See? Okay, so this is the first textbook. It's the second edition. Pretty convenient to use and read. All right, we're done with the first part. The first small session, Introduction to Data Science. Any questions? All right, then let's move on to the second small session, which is R Basics 1. So in our class, we will use R only, R and R packages. So R is a free software environment for visual computing and graphics. And it's a very powerful tool for data science. And it's free. You can download R by clicking this link in Chrome. So after you click it, you can get a web page somehow like this. And then you can choose your operation system and version to download it. Yeah. In our class, we will use RStudio. What is RStudio? RStudio is built upon R. The first thing to install R, and then you can install RStudio. So RStudio is an open source and enterprise-ready professional software for R. So it's a kind of like it's a more formatted version of R, more professional. So the RStudio window looks like this. Let me just show you my RStudio. So it looks like this. There are 4 tabs. The upper left is R scripts. You can write some R code here and you can save it. And the bottom left is console, R console. You can type a line of code and immediately run it. For example, x equals 4. Then type x, type 4. So this is a console. You can have you can interact with R directly. Okay. And the upper right one has a few tabs: environment, history, connections, and tutorial. In particular, in environment, it will show you the objects that you have created. For example, I just created X, right? And see X is shown here because it is available in the R workspace already. Okay. X is a variable name, and this is the value. Okay. If I create a new variable, y is equal to x plus 2, and then type y, then y is created. Right? So this environment can help us to keep track of the objects, anything that is available in the workspace. But after you quit R, these will be washed off. They won't be available unless you choose to save the workspace. Usually, I don't recommend you to save the workspace. And history, yeah, so this one has all of the R code you have executed previously so far. Connections, tutorials, yeah. I rarely use these two. And then let's take a look at the lower right, the bottom right one. So 5 tabs. The first one is files. So this one, yeah, allow you to access different files in your computer, your local computer. You see this is the current space. And plus, whenever I create a plot, it will be shown here. For example, let's see, z is equal to R norm. I generate 100 standard normal random variables z, and then I just say plot z. Then the plot will be shown here automatically. So this is why RStudio is very convenient. It's shown here. And you have the option to export it. If you want to use it later, you can save it as an image or save it as PDF. And you can insert it in your future report or something. Packages. So this tab contains a list all of the packages that you have installed. And if you want to install something new, then you can just click install and then type the name of the package and install it. So this is one way to install a package. There are some other ways I will talk about a little later, but in RStudio it's quite convenient. Just click install and type the package name. Okay. And you can also update packages. So sometimes packages will be updated over the years, and if you want to have the newest version, you just choose the package. For example, I click caret. I want to update it. Just check it, and then click update. Okay, then the package will be updated. Okay. And you can also attach packages and detach packages using this tab. And also help. So this one give you some information about some functions. For example, I want to know about plot function. Just type question mark plot in the R console and run it. You see in the help tab, there will be something about it. Right? So the first one is the default scatter plot function. So this is the function I want to ask about actually. Right? Click it, you will see the documents about this function, the plot function, arguments, and examples, references, etc. So it's very convenient to seek help in R. The RStudio. Other things, I rarely use them. I will just omit them for now. You can explore them by yourself. during semester. Next, how R works. R works fundamentally by the question and answer model. You enter a line and then hit enter and get the result. R will respond, return some output for you. For example, as I said, I generated 100 random numbers from standard normal. Then after that, I can immediately create a histogram. Then I can create a plot somehow like this. So this set.seed thing we'll talk about a little later when we talk about different R functions. All right. Now first, R is a calculator. You can use R as a calculator. It has a lot of mathematics, statistics, probability functions, building functions. For example, calculate the square root of 225. You can just type sqrt 225, get the result. You can also calculate factorial, 5 factorial, just use the factorial function. So there are a lot of building math and stat functions in R. If you want to take a look at a list of functions, you can click this link, click R. So in this page, you will see some commonly used R functions in math and statistics. And also there are some capture functions that can be used to handle capture strings and probability and statistics functions, etc. It's not exhaustive. It's not a complete list. There are more functions available, but this page lists some commonly used ones. All right. How to define variables in R? So R has symbolic variables, which are just names that can be used to represent values. They are not changing. They are just something that you can assign values to. How to assign values to a variable? One way is to use this operator, less than hyphen. It's kind of like an arrow. So it's namely you assign 6 to X. So by doing this, you created a variable called X. If you type X in our console, you get 6. And alternatively, you can just use equal. Z equals, same thing. So there is a very small difference between these two ways, using this arrow or equal. There is a very small difference, but in our class, it's ignorable. So you can just use either of them. It doesn't matter. And you can create a variable based on existing variables. For example, you can let y be x squared. Square, we use this hat operator, x squared, then y will be equal to 6. Provided that x already exists, you have to create x first, and then you can call x. You can create y based on x. So it must exist. So there are some limitations about names of variables. So the name must not start with a digit or a period followed by a digit. So for example, this is not valid. You cannot assign a variable create a variable called 3x directly. It's not acceptable. You will get an error message. And there are some reserved names in R. We will try to avoid using them to define variables. But you can still use them. If you really want to use these, you can. You won't get any error message. So for example, a C is used to create a vector, and Q yeah, I don't remember what is Q. T is an R function to transpose a matrix. So these are kind of like function names or reserved constants, something. And F and T, capital F and capital T, stand for false and true in R. So try to avoid them when you create a variable, but if you have to use them, you still can. Right? Just don't confuse yourself. That's the main point. Then let's move on to talk about objects in R. So what is an object? In R, everything is an object. Variables, values, any data structure, functions, they are all objects. So objects is an abstract term for anything that can be assigned to a variable. Yeah. So there are some types of objects. The first one is array. So this is the most commonly used one in R. Arrays for arrays, elements must be of the same data type. So this is a very basic definition of an array. All of the elements in an array, no matter what dimension it has, right? No matter how many dimensions it has, all the elements should have the same data type. Vectors are one-dimensional arrays. And then a special case is a single value, a vector with only one value. So that is also considered as a vector, actually. The vector is the very basic data structure. And then matrices are two-dimensional arrays, number of rows, number of columns. And then there occasionally we will see higher dimensional arrays, like 3 or more. Right? But we rarely deal with 3-dimensional or higher dimensional arrays because our human brain we cannot process data in that way. So usually just 2-dimensional at most. So this is the first type, arrays. Lists is the second type. Lists are also one-dimensional objects. However, it is more flexible and less restricted, which means the elements in a list can be of different data types, and they can be of different shapes even. We'll see some examples later. And the last one is data frame. So data frames are special cases of list. They are kind of like a list of vectors, but these vectors must be of the same length. So consequently, you will have a rectangular shape list. Each column is an element. They all have the same length. So they look like matrices, right? Matrices. However, we allow different data types in different columns. So that's why data frame is kind of like in the intersection of array, 2-dimensional array, and list, rectangular list. Somehow like that. All right. Now let's start from the very beginning, vectors. We'll study the features and operations that we can use on vectors. First, a data vector is just an array of data. For example, we create a vector called weight using the C function. The construct C function is used to define vectors. C stands for concatenate. Or you can say combine different elements. So if you have you want to create a vector with elements that are vector that is not very long and there is no relationship between the elements, no pattern among the elements, then you can use the C function, for example. Separate elements with comma. Then directly type it, you can get the result. By the way, if you want to put 2 statements in one row, you need to use semicolon to separate them. Okay, so this is the same with in Python. And then you can do calculations with vectors, just like ordinary numbers. For example, I create another vector called height with 6 elements too. Then immediately, we can calculate a vector of BMI using these two vectors. Just type weight divided by height square. Then we got this. So in R, all the calculations are element-wise, which means it will try to do the calculation for each pair of data element-wise. So it's a very good feature. All right. Then let's talk about basic data types in R. There are 5 basic data types: integer, numeric, complex, logical, and factor or string. So integers are like this. Numeric, so this is a larger group which contains integers. So real numbers. Complex, something like this. We rarely need to deal with complex numbers. Logical values, true, false. So the full value is capital true, all capitalized, all capital letters, true or false. So this is different from Python. Python is TRUE, only T is capitalized, but in R, all of them. And abbreviations, T and S. Character strings. Character strings must be quoted. You either use double quote or single quote. It doesn't matter. So these are the 5 basic data types in R. And consequently, there are different types of vectors. Numeric vectors, character vectors, logical vectors. Really depends on the values, the data type of the elements, right? Because we have just learned that in vectors or in arrays, all of the elements should be of the same data type, right? So the type of data determines the type of vector. Let's take a look at logical vectors first. Numeric vectors are very familiar. We can just skip that. So we start from logical vectors. So they can take values true or false or missing. In R, NA stands for missing values. You may create a logical vector using the C function. And if you type L, you'll see the full values of them. And sometimes a logical vector is a result from relational expressions, basically based on some comparison statement. For example, BMI, we just calculate the BMI vector, right? And then if we compare BMI with 25, then we can get this logical vector. So basically, it will take each value in BMI and compare it with 25. And if it's greater than 25, it will return true. Otherwise, it will return false. So this is also a representation, an illustration of element-wise calculation in R. Right? Although the left-hand side of the inequality has 6 elements, the right-hand side only has 1 value. It doesn't matter. Right? It will just do it. It will just kind of like make them have the same dimension and do the comparison. Yeah. All right. Character vectors. You can create character vectors using the C function again. So for example, Abby, Becky, Cassie. So these are 3 student names. And R has 2 built-in character vectors. One is called letters, lowercase letters. If you type it in R, you will see the 26 letters, English letters coming out. And this letters contains the capital letters. So if you want to, you can use them if you want. For example, you can use them to to assign group names or to assign cluster names, etc. And there is a special type of vector. So far we know there are like numeric vectors, logical vectors, vector vectors. So there is something very special, which are called vector type vectors. It is because in practice, many times categorical variables are coded as integer variables. So for example, you see we can use 0, 1, 2, 3 to represent different pain levels. And we call it pain. So when the pain vector is created is a numerical vector. It has numeric values. However, this 0, 1, 2, 3 actually represent levels of pain, but they are not literally numbers like exact value of pain. It's hard to define. Right? So in this case, it's better to convert it to a vector type vector, which means they are still essentially numeric, but they are not treated as a numeric vector anymore. You can use the vector function to convert it. Just put the original numeric vector in it and specify the levels. So you see, we name the new vector as pain, which means it's vector pain. And then if we type f pain, you see this. So these are the values in f pain, and below it, it shows you the levels of pain, 0, 1, 2, 3. So furthermore, if you want to make the levels more interpretable, easier to understand for readers of your report, you can rename the levels using strings. For example, you can just use the levels function. So apply the levels function on f pain and use a vector of vector strings to define the 4 levels, 0, 1, 2, 3 in the same order. Then if you type f pain, you see the vector completely changed. Okay. So the first row still contains the values of f pain. So 0 is none, right? 3 is severe. And the second row contains the character string level. So this is vector type vectors. Sometimes if we want to avoid confusion or errors in computation or regression analysis, we might need to convert the numeric vector to a vector vector. Next, missing values. In R, the formal missing value is denoted by NA, capital NA, stands for not available. And NA is a recognized element, which means it's a valid element. You can directly call it and use it in the definition of something even. For example, we can create a vector X which contains a missing value. So notice that in R Markdown, it is highlighted in red. So this is a valid value. It's not a character string. Character strings must be quoted. Don't forget, must be quoted. But NA is not quoted. And functions have special actions when they encounter missing values. And may have arguments to control the handling of missing values. If you don't handle it, then missing values are contagious, which means if there is any missing value in the calculation in the data set, in the vector, then the result will be missing because the function does not know how to deal with it. For example, if you calculate the mean of this x vector, which has a missing value, you get the missing value. However, you have the option to ignore the missing value. Just need to add this argument, NA.Rm equals true, which means remove missing values in calculation. Then you get the valid result. And NA is not a capital value. So this example shows you the difference. So this first NA is a missing value. This quote NA is not, is a calc string. So R treat them differently, apparently. So this is a calc string, this is missing. And there are some other functions that you can use to deal with missing values manually. NA.omit, exclude, fail, etc. So for more information about these functions, you just need to type $NA.omit in R console and hit enter. Then in the help page, you will see all of these functions listed and their corresponding functions and usage will be listed there. Quite convenient to use. And R has some functions that we can use to understand vectors, to learn the features of vectors. Since vectors are one-dimensional, it makes sense to measure the length of them. So the length function can be used to measure the length. And it can also be used to measure the length of a list. As I said, lists are one-dimensional objects. So you can use the length function to check the length of a list as well. And class, this one returns the class of an object. What is class? Class is a property assigned to an object that determines how generic functions operate with it. It's not a mutually exclusive classification. So class only cares about what math, for example, what math operation, what operations can be applied on the object. It does not care what data type exactly it is. So that's why it's not mutually exclusive. It's not a mutually exclusive classification. And which one is mutually exclusive? The mode function. So this one returns the mode of the object. It gives you the information about the basic data structure, which are corresponding to the atomic modes in R: numeric, character, complex, logical. So they are aligned with the basic data types in R, but class is not. For example, the following example shows you the difference between mode and class. Remember the F-pane vector? We have converted to a vector. This is a vector type vector, which has character string values already. If you check the mode of it, it's still numeric, because originally when it was created, it was a numerical variable, a numerical vector. So the mode of it is still numeric, right? Although it looks very character string-like vector. If you check the class of it, is vector, which means arithmetic functions are not appropriate for this anymore. For example, if you want to calculate the mean of F-pane, you get a warning message. Argument is not numerical or logical. Although the mode of it is still numeric, you cannot calculate the mean of it anymore. The class function determines what operations can be used on the vector. This is the difference. And there are some is.dot functions that we can use to check data type, types of data. For example, is.logical, is.numeric, character, integer. And also, there are two functions that we can use to determine some special features of a vector. So is.null, this one determines whether an object is empty. To pay attention, this is only about whether or not the object is empty. There's nothing in it. So this is mainly to represent the list with zero length, and is often returned by expressions and functions whose value is undefined. And is.na determines if an element is missing, not available. So let's see the difference using this example. So x has three values, 3, 1, and a. If you apply the is.now function on it, you get false because it is not empty. There are three elements in it, although one of them is missing. Okay. However, if you apply the is.na function on x, you will get false, false, true. It will take each value and check if it is missing or not. So not missing, not missing, missing. The last one is missing, so that's true. Okay. Now you see the difference. Is.now only cares about whether or not the object is empty. Is.na will actually check each element and see if it is missing or not. So these are different, right? Two different functions. And lastly, there are some aggregation functions in R, or aggregator functions. Aggregator functions will change the dimension of your data. For example, it will take a vector and then return a single value or a few values. It will change the dimension. For example, the sum function, it will only return one value, right? If you feed a vector to it, it will return one value. Also, the mean function will return one value. So it's a kind of like a summary function. It's called aggregator function. And the range function actually will return two values, both the minimum and the maximum. So in R, the range function will return two values. It's not the difference between min and max. It's a vector of two values. But anyway, it will change the dimension of the data you feed into the function. And the summary function is a very useful function in R. For example, I create a vector called x. So this is a shortcut of creating a vector of consecutive numbers between 1 and 100. And then if you apply the summary function on it, it will calculate the minimum, maximum, the median, first quartile, third quartile, and the mean of it. So it's a quite useful function to summarize numeric variables. And pay attention, the standard deviation is not given. Only the mean is given. And also, if there is any missing value in the vector, it will automatically ignore it. And also it will count number of missing values and provide it in the table. So there is a missing value, then there will be another column at the end. So that is the number of missing values. And then last one, functions you can change that can be used to change type of object. So yeah, this is sometimes it is also useful. For example, fping, which is a factor type variable already, you can change it back to numeric and check the data type is numeric. So that is all for this section. It's all about some R basics. Whoops. Any questions so far? Sorry. I know for some people this is kind of familiar. Most people who have taken STAT 1000 have some knowledge in R programming already. But because our class does not require knowledge in R, so we have to cover this part. Okay? And I believe it's a good review for everyone. All right, let's move on to R basics 2. Let me see. Actually, yeah. Okay, great. Yeah, I want to save some time for our markdown, so let's just go ahead and talk about our basics too. Yeah, we'll talk about data structures in R again in details, and then how to subset data for different data structures. And we will briefly talk about built-in functions in R, in particular probability functions in R, and then packages in general. Okay, so first, let's see the functions that we can use to create vectors. We have seen this. The C function stands for concatenate. So again, if you want to create a very short vector with some very unique values in it, you can just use the C function. You can create a numeric vector. You can also create a text vector. Don't forget to use quote if you create a text vector. And the C function not only can concatenate single elements, single values, it can also be used to concatenate vectors and single values. Okay, so it's very convenient, very flexible. For example, I create two vectors, x and y. Then we can combine them all together, x, y, and 10. So see, I have a bigger vector, which contains elements in x, y, and a single value 10. So C is a quite flexible function to create a vector. It's also a very basic function. The second function that we can use to create a vector is the SEQ function. It stands for sequence. If you want to create a vector of consecutive numbers, then this one is more convenient to use. And for example, I want to create a vector of consecutive numbers between 0 and 10. We can just use this SEQ 0, 10. Start and end value. So by default, the jump is 1. By default, the jump is 1. If you want to want a sequence in jumps of 2, for example, you want to list even numbers only, then you can add a third argument, 2. So this is a jump. And the arguments actually have names. The first argument is from. The second is to. The last one is by. So this is a complete syntax for this function. But if you put these arguments in the order, in the default order, you don't have to use the argument names. You can omit them. So it's totally fine. And if the step size is 1, you can also use this notation, this syntax, 0, 10. This is consecutive numbers between 0 and 10. So you see, if you have a very big vector to create and there is a pattern, consecutive numbers, you can use SEQ. And the last one is REP, stands for replicate. So it can be used to generate repeated values. For example, generate a vector of 10 ones. So just specify the value you want to repeat and the number of times. And for character vector, you can also apply it, the repeat function, replicate function. For example, V is a vector of A, B, and C. Okay. And then you can repeat V 3 times. Then this is the result, A, B, C, A, B, C, A, B, C. Like the entire vector is repeated 3 times. If you don't want to repeat all of the elements the same number of times, then you can do this. For example, I want to repeat A once, B twice, and C 3 times, and we can do this. So it's pretty flexible. Many times if you want to create for example, you want to create a toy data set by yourself, right? You want to create a categorical column, categorical variable column, and with some labels, A, B, C, you can use this repeat function, right? Just design a pattern by yourself. All right. Matrices. The vectors are one-dimensional arrays. Matrices are two-dimensional arrays. There are a few ways to create matrices. The very first way is to create a matrix from a vector by redefining the dimension of it. So you see, I first create a vector of x called x, contains consecutive numbers between 1 and 12. Then I apply the dimension function. So I redefine the dimension of x to be 3, 4. And so that means there will be 3 rows and 4 columns. Then if I type x, you see x is not a vector anymore. Originally it's a vector. So now the dimension has been changed to a two-dimensional array, a matrix. So this is one way to create a matrix. And notice that the cells in the matrix are filled column major. So you see 1, 2, 3, 4, 5, 6, etc. Right, so this is default behavior, right? Fill along the columns. And R actually has a matrix function that you can use to create a matrix. So we just call it matrix. And the first argument is a vector of values, and then number of rows, and then number of columns. Okay? And then you have this still column major. So the 3 arguments are data, and row, and column in this order. Okay? And if you want to change the filling behavior, you want to fill the matrix in a row-wise fashion, then you just need to add an argument by row equals true. Then it will be filled in this way, 1, 2, 3, 4, 5, 6, 7. So this is the second way to create a matrix. You can add row or column names to a matrix. Just use the col names function or the ROW row names function. Okay. For example, I can call the columns A, B, C, D. Okay. So this function just add column names to M1. So this function add row names to matrix 3 and 3. And you can transpose matrices using the T function. Transpose means change the original columns to be rows and rows to be columns. Okay. And last one, we can also create matrices by gluing vectors together or combining or binding vectors together. There are 2 functions, cbind and rbind. Cbind means column bind. So you bind, for example, A is 1, 2, 3, 4, B is 5 to 8, C is 9 to 12. If you use the cbind function, A, B, C, then you have a matrix like this, right? So column bind. Similarly, you can stack them together using rbind, row bind. So this. You can also use the cbind function to add a column. So you see M4 is already a matrix. I can add another column using a cbind function. You can also add another row at the bottom using the rbind function. All right, I think that'll be all for today. So tomorrow we'll continue to talk about R basics